Hello friends, welcome to Learner's Planet. Friends, this is our fifth session for probability. In the previous session, we discussed good number of problems. We'll be continuing taking more problems in this session even. And I expect that you might have revised the previous sessions and you might have revised the sessions of permutation combination as well, right? So let's begin this session. Now friends, let's see this question. A person writes 4 letters and addresses on 4 envelopes. If the letters are placed in the envelopes at random, what is the probability that all the letters are not placed in right envelopes? That means at least one letter and envelope combination is incorrect, right? Now friends, it's very simple question. Suppose we have 4 letters A, B, C, D and their 4 envelopes are A1, B1, C1, D1. So only one combination will be correct, right? That means A should get into A1, B should get into B1, C should get into C1 and D should get into D1, right? All other combinations will be wrong, right? So in all, ABCD can be arranged in A1, B1, C1, D1 in 4 factorial ways, right? Because we have 4 letters and 4 places. So 4 factorial, that means total number of ways are 24, and out of this just one way is correct, so remaining 23 ways are incorrect. So the probability that all the letters are not placed in the right envelopes, that means at least one letter should get into the wrong envelope, will be 23 by 24. Right? Now we have this question. In shuffling a pack of playing cards, 4 cards are accidentally dropped. The probability that the missing card should be one from each suit, right? So precisely if the cards are dropping or maybe we are drawing 4 cards, the probability will remain same. So we have to find out the probability of precisely 4 cards, like we are drawing 4 cards and 1 card is from each suit, that is 1 from spade, 1 from club, 1 from diamonds and 1 from hearts, right? So in all, out of 52 we are drawing 4 cards and that should be 1 card from each suit, right? So this is the probability, right? Each suit has 13 cards. So 13 from spade, 13 from club, 13 for diamonds and 13 from hearts, right? Now we have to just solve it. It's 13 into 13 into 13 into 13 by 52 into 51 into 50 into 49 into 4 factorial, right? So just simplify it. The numerator is 13 cube, that's 2197, and denominator is multiple of 25, so it suits. Just have an around idea of the calculation. In most of the exams, final calculation is not asked, but sometimes even if it is asked, you need to calculate that, right? So 2197 by 20825 will be the correct choice, right? Now this question. A cricket club has 15 members of which only 5 can bowl. If the names of the 15 members are put into a box and 11 names are drawn at random, find the probability that out of 11 members team containing exactly 3 bowlers. So precisely there are 10 people who can bat and the 5 can bowl. So we have to find out 11 persons out of 15, right? Now out of 5 bowlers we need to select 3, so it's 5C3, and simultaneously out of 10 batsmen we have to select 8, right? In all, 8 plus 3, 11. So this is what the probability is. Now 5C3 is what? 5C2, so it's 5 into 4 by 2. 10C8 is also 10C2, so it's 10 into 9 into 2. 15C11 is 15C4, so it's 15 into 14 into 13 into 12 by 4 factorial, right? I just rewrite over here. So it's 5 into 4 into 10 into 9 into 4 into 3 into 2 by 2 into 2 into 15 into 14 into 13 into 12, right? Your 13 is there, so denominator should be multiple of 13. Rest we just see is 5 and 3 15, 15. Then that's 4 3s are 12, 3 3s are 9, then 2 7. So precisely we are getting 30 by 91, right? So this is 30 by 91, right? I hope you are clear. Now we have this question. The letters of the word melon cow are arranged in all possible ways. The chances that there are exactly 4 letters between M and E. Now friends, first of all, let's see, there is no repetition of the letters. So now we want 4 letters between M and E. So what I do, M, 1, 2, 3, 4 and E, right? Then we have how many letters? 1, 2, 3, 4, 5, 6, 7, 8. Now we have this 6 letters and now we have 2 more letters, whatever the letters are, maybe letter 1 and letter 2, right? Now I just take it as 1 letter because we want 4 letters in between M and E, and this is 2 and this is 3, right? Now friends, the most important thing over here, which 4 letters will come over here? In all, we are having 8 letters. Out of these 8 letters, M and E are already there, right? Now which 4 letters will come over here? So out of remaining 6 letters, we need to select 4 letters, right? Now this 4 letters can be rearranged in 4 factorial ways, right? Now this is the arrangement when we have chosen 4 letters and we are arranging them between M and E, right? So this is the probability of, this is the way, like combination of arrangement of this particular circle. Now we have this circle plus two letters. Now the 3 things can be arranged in 3 factorial ways, right? And do not forget to multiply by 2 because we want 4 letters between M and E. So the order of M and E can also be changed, that is E and M. So I just take 2 also, divided by the total number of cases, that is 1, 2, 3, 4, 5, 6, 7, 8. That's 8 factorial, right? So we have to solve this. Now what's 64? 64 is 62. So this is 6 into 5 by 2. Then this is 4 factorial. I just cancel it out. 4, 3, 2. 3 factorial. I can cancel it from here, right? So it's 64 into 2 by 2 into 8 into 7 into 5. So it's 5. This 2. This 3. 4. So it's 3 by 28, right? So various cases are involved in this problem. First of all, we have to choose the 4 letters which will come between M and E. Now we have to arrange these letters between M and E. Then we get this a perfect, like we can say a box that we have to arrange with other 2 letters. The box may be positions in between or at the end or at the beginning. So various ways are there to arrange this box with these 2 remaining letters, right? Apart from that, the order of M and E can also be changed. So do not forget to multiply by 2, right? So good problem. Good number of concepts are involved in a single problem. So the probability is 3 by 28, right? If you forget this too, you'll be getting a wrong answer. So be very careful about it, right? Most of the student like make this mistake only. Okay. Now friends, let's say this problem. 3 numbers are chosen at random from 1 to 20. What is the probability that they are consecutive? So total number of cases, that is total possible cases, will be 20 C3, as we are selecting 3 numbers out of 20, right? Now the number should be consecutive. So what are the, how many possibilities are there? It's 1, 2, 3, 2, 3, 4, 3, 4, 5 till 18, 19 and 20, right? So we have 1, 2, 3 till 18 sets are there, right? So the favorable cases are 18. So it's 18 into 3 into 2 by 20 into 19 into 18, right? So that's 3 by 190, right? Very simple and conceptual question. Friends, further we have a conceptual question. From a bag containing 100 tickets numbered 1, 2, 3 till 100, one ticket is drawn. If the number on the ticket is x, the chance that x plus 1 by x is greater than 2 is. One important thing over here, that if we have two positive real numbers, right, for just the concept will be useful at other places also. So if we have like positive real numbers I'm talking about, right? Suppose x, or maybe I take n is a positive real number, then n plus 1 by n will always be greater than equal to 2, right? That's very, very important property of positive real numbers, right? So if n is any positive number, n plus its reciprocal, that's 1 by n, will always be greater than equal to 2. And in the single case, it will be equal to 2 when n is equal to 1, right? So in this case, n plus 1 by n will be equal to 2, right? In all other cases, n plus 1 by n will be greater than 2, right? So in this, we have 100 numbers. So 99 numbers will produce x plus 1 by x greater than 2, right? Only like this number 1, if x is 1, then 1 plus 1 will be equal to 2, but we want greater than 2, so all other numbers will produce the results greater than 2 if written in x plus 1 by x format, right? So we have 99 choice out of 100, right? So if the number on the ticket is x, the chances that x plus 1 by x is greater than 2 will be 99 out of 100. Only 1 will not be there. Okay, and this is really an important property, will be used at various places. So just remember that. And do not forget that we are talking about positive real numbers. Now friends, we have this question. One ticket is selected at random from 100 ticket numbers 000102 till 99. Suppose S and T are the sum and product of the digits of the number on the ticket. Then probability of getting S is equal to 7 and T is equal to 0. Now the two digits may be A and B. That means A plus B to be 7 and A into B to be 0. That means one of the number, that is either A or B, should be 0, then only the product will be 0, right? And if you wish to make the sum as 7 and product as 0, and keeping that in mind that at least one number or exactly one number is 0. So we have just two possibilities, that is 7 plus 0 and 0 plus 7. That means the number should be either 70 or 7, right? So we have 100 numbers. So out of 100, 2 are the favorable choice, that is 70 and 7. That's 70 and 07. So 2 out of 100, so 1 out of 50. Okay. Now let's see this question. 7 tickets are drawn successively with replacement from a bag containing 80 tickets numbered 1 to 80. The chance that all the tickets bear number divisible by 10. Now friends, since 7 tickets are being drawn with replacement, that means each and every ticket will be drawn from 80 tickets, right? Now the favorable chances with us is the number should be divisible by 10. So we have how many choices? It's 10, 20, 30, 40, 50, 60, 70 and 80, right? So for every number we have these many choices, that is 8 choices, right? So for the first ticket, total possibilities are 80. Out of that, 8 are favorable. For second, the same, right? So for all the 7 tickets, it's 8 by 80 raised to 7, or we can say 1 by 10 raised to 7. Okay, just be careful that it's with replacement. That means whatever the ticket you are drawing, you are putting it back in the group. Okay. Now friends, we have this interesting question with us. 3 of the 6 vertices of a regular hexagon are chosen at random. The probability that the triangle with these vertices is equilateral. Now I just draw regular hexagon over here. Wait a moment. Now this is the regular hexagon, and we have taken 3 vertices. So the total number of chances are, that is total number of triangles will be 6C3. That's, we are selecting 3 vertices out of 6. So these many triangles will be formed. Now what? How many of them will be equilateral? See this, this and this. This is the one triangle that is equilateral. That means if we choose alternate vertices, then only we'll be getting the triangle as equilateral. So we have one this and other this, right? So we just have 2 triangles that is equilateral, right? So it's 2 by 6 into 5 into 4 into this 3 factorial, that's 6. So this 1 by 10, right? Now friends, further we have an interesting question with us. From a set of 4 positive and 4 negative numbers, 4 numbers are chosen at random without replacement and are multiplied. What is the probability that the product is positive? Now, since there are 4 positive and 4 negative number, maybe A, B, C, D, these are the 4 positive, and minus P, minus Q, minus R, minus S, these are the negative numbers, right? Now if we want, and we have to draw 4 numbers, right? We have to choose 4 numbers. Now various cases will be there. Either all the 4 numbers are positive, all the 4 numbers are negative, 2 are positive, 2 are negative, right? So we have this 3 cases with us when the product will be positive, right? So the total number of cases will be 8C4, right? Now we have to take the favorable cases. So that's all 4 are positive. That means we have to select 4 out of 4 positive number, or all the 4 are negative. That means further we have to select 4 out of 4 negative numbers. Then 2 are positive and 2 are negative. So out of 4 positive numbers we are selecting 2, and out of 4 negative numbers we are selecting 2, right? So now just simply solve it. 4C4 plus 4C4, that's 1. Plus 1, then 4C2 is 4 3s are 12 by 2, 6 into 6, 36 plus 2, 38, and this is 8 into 7 into 6 into 5 into 4 into 3 into 2, right? So this 19 by 35, right? Quite an interesting problem. Now we have a dice with 1, 2, 3, 4, 5, 6, as we are rolling it for 4 times. Out of the 4 face value obtained, the probability that minimum value is not less than 2 and maximum value is not greater than 5. That means the number should be 2 to 5 inclusive, right? That's 2, 3, 4, 5. So we have 4 choices for the number to be appeared, right? And in all we have 6 choices. For the first roll we have 4 out of 6. These are the favorable choices. Same for the second, same for the third, and same for the fourth, right? So that's 2 by 3 raised to 4, or we can say 16 by 81. Okay. Now let's see this problem. Two numbers x and y are chosen at random from the set of first 30 natural numbers. The chance that x square minus y square is divisible by 3. A very interesting and conceptual problem, friends. See, if x square minus y square to be divisible by 3, what are the factors of x square minus y square? That's x minus y into x plus y, right? So this is x minus y and x plus y, right? Now if this product is divisible by 3, then at least one of them should be divisible by 3, right? Either x minus y or x plus y, right? Now these are the 30 natural numbers, and what is the format of natural number? I just mentioned it over here. I'll be discussing this problem in detail. After that you'll be able to solve it easily. once the concept is clear to you, right? Now each and every number is in the format of, see, this is, if we start from 1, so it's 3x plus 1, 3x plus 2, 3x plus 3, then further 3x plus 4, that will be in 3x plus 1 format, 3x plus 5, that's 3x plus 2 format. So if we start from 1, 1 will be in 3x plus 1 format. That means if x is 0, we'll be getting 1. 2 is in 3x plus 2 format. That means each and every number is multiple of 3 or will leave remainder as 1 or 2, right? So we have 10 numbers, that is 3x plus 1, 3x plus 4, 3x plus this 4 plus 3, 7. These are the numbers, that are 10 numbers which will leave remainder as 1 if divided by 3, right? So 10 numbers like this. Similarly, 10 numbers like this and 10 numbers like this. So we can say that's 3x plus 3 format or just 3 format, 3x format. That means the 10 numbers are multiple of 3, right? I just write it over here for your conveniency. Wait a moment. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and so on, right? Here it's 30, 29 and 28. Now if you would just see the first sequence, if you divide any number by 3, you will get remainder as 1. Here you'll get the remainder as 2 and here you'll be getting the remainder as 0, right? Now we have to make the various combination. Just listen to me carefully. The problem is really going to be difficult one or be a different one, not difficult but different, right? Now what's that? See, if we choose any two number from this series, then the difference will be definitely multiple of 3. Why? Because both the numbers will be in 3x plus 1 format. So if we deduct one 3x plus 1 format from the other, the 1 will be cancelled and we are left with 3x format, right? You can see that's this difference between 4 and 1 is 3, 1 and 7 is 6, 4 and 10 is 6, 7 and 28 is 21. So the difference of any two numbers from this sequence will be divisible by 3. So we can choose any two numbers from this sequence. So they will be definitely, their difference will be definitely divisible by 3. So I just write 10C2 for the sequence. Similarly, all the numbers in the sequence, these are in 3x plus 2 format. So if you find out the difference, 2 will get cancelled and each difference will be multiple of 3. So you can choose two numbers from even this sequence. So either from this sequence or this sequence. So I further write 10C2 over here, right? Now similarly, in this case, if you choose two numbers, any two numbers, that difference as well as sum, both of them will be divisible by 3 because both the numbers will be in 3x format, right? So what you can do, you can choose the three numbers from these 10 numbers, right? So individually we have taken the three sequence and got these many combinations. Apart from that, if I take one number from this and one number from this, that is 3x plus 1 format and 3x plus 2 format, then their addition will be multiple of 3, right? So what I can do, I can choose the fourth event with us is, I can choose one number from the sequence and one number from the sequence. So it's 10C1 into 10C1. Getting my point? So we have got the total number of possibilities when either sum or difference or both of them will be divisible by 3, right? Now these are the favorable events, and what is the total number of events that we are choosing? Two numbers out of 30 numbers. So the total number of events will be 30C2. That will be in denominator, right? So it's 30C2. I just solve it out. So that's 10C2, 10C2, 10C2 3 times. So 3 times 10C2, 10C2 is what? 10 into 9, 90 by 2, 45. So 3 into 45 plus this is what? 10C1 into 10C1, that's 100. But that is 30 into 29 into 2, right? So 45 into 3 is 35 plus 100 is 235. So it's 235. It's 15 into 29. So 5 4s are and 5 7s are and 5 3s are. So it's 47 by 29 into 3, that's 87, right? So the probability of this event will be 47 by 87, right? So this is the answer. It's really a great problem. Just revise it if you are not clear. Though it's very easy once you are like getting the concept. Now, further we have an interesting problem. A box contains 50 tickets each bearing one of the numbers from 1 to 50. 5 tickets are drawn out at random and arranged in ascending order such that x1 is less than x2. This way, we have to find out the probability that x3 is 30. That means the middle number is 30, right? So in all, the total number of events will be like 50C5, right? So this 50C5, the total possibilities are. Now we have to find out the number of cases when the third number is 30, right? Now what's that? See, the third number is 30 and we have to arrange the numbers in ascending order. Just listen to me very carefully. That means these two numbers should be selected from 29 numbers, right? Which are less than 30. So we have to select these two numbers from 29 numbers and these two numbers from the remaining 20 numbers. So this is 29, this is 30 and this is further 20 numbers. So these two numbers should be selected from remaining 20 numbers, right? So it's 20C2. Okay, and in all we have 50C5, right? So since we are choosing these two numbers from less than 30, so obviously they will be before this third number, that's 30, and these number we are choosing from more than 30, so they will be after 30, right? If we arrange them in ascending order. Okay, you don't have to make any arrangement because we have to arrange the numbers in ascending order, and if we choose any 5 numbers, then there is a single way of arranging the number in ascending order, right? So do not make any sort of permutation over here. This is wrong, right? So this what 29C2, 20C2 by 50C5. So this option B is correct, right? If at all you have to solve the problem in exam, you can very well solve it. Or if options are like this, you don't have to solve it, right? It's a really great problem. Now friends, let's see this problem. The probability that a number selected at random from the set of numbers is a cube. Now if it has to be a cube, then we have 1, the cube of 2 is 8, cube of 3 is 27, 64. So we have just 4 choices, right? So 4 out of 100, that's 1 by 25, right? Now let's try this problem. 3 integers are chosen at random from the first 20 positive integers. The probability that their product is an even number. Now if we want the product to be even number and if we are selecting 3 integers, that means at least one of them should be even, right? Then only the product will be even. If at all one even number is there, then also not a problem because odd into even is even only, right? So what we do is we just find out the probability that there is no even number selected at all, right? So in all we have 20 positive integers, so we have to select 3. And what are the favorable cases when there is no even number at all? That means all the 3 numbers are selected from the 10 odd numbers. So this is the probability when there is not even a single even number, right? We deduct this probability from 1. So in the remaining cases, we have at least one even number. So if at least one even number is there, it will produce the product as even, right? So it's, I just calculate 10C3 by 20C3. So that's 10 into 9 into 8 by 20 into 19 into 18. So it's 2 by 19. So it's 1 minus 2 by 19, that is 17 by 19. So 17 by 19 is the probability that the product will be even, right? So this is the answer. I hope you are clear. Now friends, let's see this problem. The probability that in a family of 5 members, exactly 2 members have birthday on Sunday. Now we just have to choose, first of all, we have to find out the total number of possibilities, right? For every member, we have 7 options, that is Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, right? So in all, For first member we have 7 choices, for the second member we have 7 choices. So in all the total cases will be 7 raised to 5. Now we have to find out the favorable cases. Now exactly 2 members should have birthday on Sunday, right? So first of all what I do is I select 2 people out of 5. So this is 5C2. I have selected 2 people. Now this 2 people will have the birthday on Sunday. So there is no choice of having birthday other than Sunday. So they just have one choice, that their birthday is on Sunday. Now remaining three people have, each people have 6 choice, right? Their birthday is any other day except Sunday. So 6 for the first person, 6 for the second person, and 6 for the third person, right? So it's 5C2, that's what? 5 into 4 by 2, that's 10. So it's 10 into 6 cube by 7 raised to 5. Getting my point? So it's the probability that exactly 2 members have birthday on Sunday. We selected 2 persons because these 2 are not particular person. So we have to select 2 persons out of this 5. So this 5C2 combinations will be there. Now they have just one choice, that their birthday is on Sunday. Remaining 3 people each have 6 choices, as their birthday is not on Sunday. So their birthday is any other day except Sunday, each 3 people, right? So this is the total favorable cases, and these were the total cases. So this is the probability, right? Uh, we'll be doing more problems in the next session. Do revise this session and the previous ones. Bye bye.